We are now going to solve equations of the quadratic form using substitution. The following are examples of equations of the quadratic form. So what we first need to do is decide what makes these seemingly different equations similar. Go ahead and pause the video and see if you can look at these three equations and find some similarities. Okay, hopefully you found that each one of these equations is already equal to 0. So that's the first similarity. The next similarity that I want to talk about is that they each have three terms. So the first one has 1, 2, 3 terms. The second one has 1, 2, 3 terms. The third one has 1. This is all one term, separated by a plus. 2, that's a one term, and that's 3. So each of them has 3 terms. Next, I want you to notice that the third term is always a constant or just a plain number. So the last one is 9, the last one is 2, and the last one is 18. Notice the third term is always just a constant. The next similarity is that each variable or base is the same on the first and second term. So, for example, we have an x here and an x here. Now, I know they have different exponents, but they have the same base. An x here and an x here. Even here, x plus 3 is the whole base because the x plus 3 is being raised to the 2, so the whole base is the same. And the last, and probably one of the most important parts, is the exponents, the relationship between the exponents of the first term and the second term. So let's take a look at those. The first term of the first equation is 4, which is twice as much as 2. 2/3 is twice as much as 1/3, and this 2 is twice as much as that invisible 1 right there. So we can say that the exponent of the first term is double or twice the exponent of the second term. And this is really, really important. You have to have that doubling property in order to be an equation of the quadratic form. So each of these 5 similarities to the right here qualify the equations to be of the quadratic form. Okay, so just to be clear, the quadratic equation is ax squared plus bx plus c equals 0. So of the quadratic form, we have to have a something squared plus b times something plus c equals 0. So a quadratic equation is just simply ax squared plus bx plus c, but if it's similar to the quadratic equation, meaning a times something squared plus b times that same something plus c equals 0, then we can say it's of the quadratic form. Let's go back and look at these 3 equations one more time. I can rewrite the first equation as x squared minus 8 times x squared minus 9 equals 0. Something squared minus 8 times something minus 9 equals 0. So this is of the quadratic form. And why does that work? Because it's double here, okay? So of the next one, we have 5 times x to the 1/3 squared plus 11 times x to the 1/3 plus 2 equals 0. Notice that whatever's in the parentheses here, on the first one, x squared and x squared has to be the same. X to the 1/3, x to the 1/3 has to be the same. Now this next one is already set up for you. The x minus 3 is the same as the x minus 3. Notice that the 2 is on the first exponent and a 1 is on the second exponent. So these are all of the quadratic form. Next, we're going to go through the directions for the quadratic form. For step 1, it says identify the equation as a quadratic form. And then set the equation equal to 0. Now, let some variable, and we usually use u. A lot of the books use the letter u. Technically, you can use whatever letter you want, but I'm going to go ahead and keep using u and call it u substitution. So we're going to let some variable u be equal to the original equation's middle term, or the b term. This is very, very important to write this down because you're going to use it again. Now, I want you to substitute on step 3 the new variable u into the equation to get the quadratic equation, and then solve for the new variable u. A lot of students think that they're done at this point because they've solved for something, but the original problem wasn't in terms of u. So to get it back to the original variable in step 4, to solve for the original variable, I want you to substitute the solutions back into equation 1 and then solve. Now, you must check some of your problems. So I'm going to put this as step 5. So you need to check your solutions. It's mandatory if your equations include rational exponents. If it doesn't include rational exponents, then it's just an optional check to make sure that you did it correctly. So next we are going to solve equations of the quadratic form. So step 1 says, let's make sure that it is of the quadratic form. So first of all, you have 3 terms that set equal to 0. The last term's a constant. And if you look at the exponents, we have the 4 is double the 2. So this is of the quadratic form. So then the step 2 says, let u equal the middle terms, that's the 8x squared, variable part. That's this one right here, the x squared. So we're going to let u equals x squared. This is our little translation, okay? So that's my translation key. It's as if I can't solve the equation in x's because it's too hard. So what I'm going to do is I'm going to translate this equation into u's. It's like if someone asks you a question in a foreign language that you don't know, let's say you don't know German and they ask you a question in German, well, you have to then translate it, take out your little Google Translate, translate that into English, think about your answer, reply, but you can't reply back in English. You're going to have to put it back in Google Translate in order to translate it back into the language that they understand. Okay, so think about that analogy. I have to solve my equation in x's, but I can't because x to the 4th is too big for me. So what I'm going to do is I'm going to translate this into u's. First, want to write this out in quadratic form. We know that this is x squared squared, which is x to the 4th, minus 8 times x squared minus 9 equals 0. So every time I see an x squared, I'm going to plug in a u. So I have u squared minus 8 times, instead of x squared, I'm going to write u minus 9 equals 0. What we've now done is we've turned this problem from x's, that were x to the 4th, which is too big for us, into u's, which is now just u squared. Now, u squared, that's something I can solve. I know how to solve these pretty simply. So I'm going to go ahead and solve this. This is u minus 9, u plus 1, set each of the factors equal to 0. So I'm getting u equals 9 and u equals negative 1. Hooray! A lot of students think, oh yay, I solved for something, I can be done. Okay, so what this is like someone talked to you in German, you've translated it to English, you've come up with an answer in English, but you can't just tell them back the answer in English. That doesn't make sense. So what you're going to have to do is you're going to have to change these u's back into x's so that they can understand what you're talking about. No one asked you to solve for u, they asked you to solve for x. So because I'm asked to solve for x, in step 4 of our steps it says to solve for my original variable x, I need to use the translation. This is like my Google Translate up here, u equals x squared. So I know what u is, so I'm going to change the u back into x squared on both of the u answers. So it says u equals 9 and u equals -1. So therefore x squared must equal 9 and x squared must equal -1. So I have another two equations here, but these are easy to solve. I can solve that using my square root method. So I have x equals plus or minus 3 and x equals plus or minus the square root of -1 is I. So I have plus or minus 3 and plus or minus I. Now I do not have to check my answers on this one because I don't have a rational exponent, so it's not required to check, so I'm not going to check on this one.